Good morning, boys. We will be starting with trigonometry now. I will be introducing the chapter to you. So first thing first is the fact that trigonometry can be used, or the laws of trigonometry can be used only for a right angled triangle. So the first thing you need to do is look for a right angled triangle. If there is no right angled triangle, please remember that the laws of trigonometry cannot be applied. So let us say we have a right angled triangle. Okay, right angled triangle ABC, right angled at the vertex B. Now, this is a continuation or next extension, let's say, or somewhat of what we studied last year about the Pythagoras theorem. When we did the Pythagoras theorem, we talked about something called a perpendicular base and the hypotenuse. We are talking about these three sides. We are talking about the perpendicular, base and the hypotenuse. Now, the side which is opposite to your 90 degrees, that means this is your 90 degrees, the side which is opposite to your 90 degrees, the longest side that we have, this is called the hypotenuse, okay, which is always your longest side. The side on which the triangle rests, that is your side BC, this is called your base. And this side is called your perpendicular. Okay, so we have the hypotenuse, we have the perpendicular, and we have the base. Now, according to Pythagoras theorem, we have studied that the hypotenuse square is equal to perpendicular square plus the base square. This for you is your Pythagoras theorem. Okay, so last year is what we have done in class 8. We have studied about Pythagoras theorem. We said that the hypotenuse square is equal to the perpendicular square plus the base square. Now, if you want to write it as per this triangle, hypotenuse, which is the longest side, is the side AC, A to C. So we write this as AC square is equal to perpendicular, which is this side, AB, plus the base, which is the side BC. Now, this is what we have done in Pythagoras theorem. Okay? Again, Pythagoras theorem, like trigonometry, can be used only for a right angle triangle. So your first job is to make sure that you have a right angle triangle. If there is no right angle triangle, Pythagoras theorem nor trigonometry can be used. Now, we normally use a Pythagoras theorem. We will normally use Pythagoras theorem when we know the length of two sides and we want to find the length of the third side. Okay, we will normally use Pythagoras theorem when we know the length of two sides and we want to find the length of the third side. Now we talk about trigonometry. Now, trigonometry normally comes in a right angle triangle again. Let's say a right angle triangle. Okay, right angle triangle again ABC, 90 degrees at the vertex B. Now, the main difference between our Pythagoras theorem and this trigonometry is when we talk about trigonometry, an angle comes into play. So let us say this. Okay, if you look at this one, which is a Greek symbol, is basically a theta. Okay, normally used to denote an angle. Of course, you can use any other symbol to denote an angle, but for common use, we normally use this word theta to denote an angle. So, when the angle comes into play, unlike Pythagoras theorem, the moment an angle comes into play, then your perpendicular and the base will change. The hypotenuse will remain the same. The hypotenuse in a right angle triangle, the hypotenuse is always the slanted side. The one which is slanting is always the hypotenuse, which is supposed to be your longest side. So this will remain as hypotenuse, as it is. When the angle comes into play, this is what you have to keep in mind. Wherever the angle is, opposite to your angle, whichever side you have, that means I have got this angle, opposite to this angle, which is your side AB, this side becomes your perpendicular. So this AB becomes your perpendicular and the remaining side becomes your base. Or the side on which the angle rests, this side becomes your base. I hope this is clear. So we have the slanted side, which is your hypotenuse. Wherever you have the angle, opposite to your angle, whichever side is there, that becomes your perpendicular. And the side on which the angle rests, that becomes your base. So let's say, for example, another right angle triangle. Let's say ABC, 90 degrees. But let us say that instead of angle C, the angle is now made at angle A. So let us say the angle comes here. Now, in this case again, opposite to 90, the slanted one always remains as the hypotenuse. That does not change. But because the angle has now shifted here, opposite to this angle, okay, straight opposite to this angle, BC now becomes your perpendicular. Okay, and therefore AB becomes your base. So that is the first thing you need to keep in mind when you are doing trigonometry. Okay, you need to keep in mind where your angle is. Wherever your angle is, opposite to your angle becomes the perpendicular. Okay, angle is here, opposite to this one becomes your perpendicular. And the remaining one becomes your base. Hypotenuse will always be your slanted side. Please keep in mind, hypotenuse is always the slanted one, always the longest side, okay, and then the remainder. So now, when we do trigonometry, we try to first learn somewhat like a poem, and we learn them as some people have curly brown hair turned permanently black. So this is the poem that we learn. Okay? That gives us some of the formulae that is there in trigonometry. So we learn this poem as some people have curly brown hair. Okay, this is supposed to be hair, H-A-I-R, turned permanently black. Again, the spelling mistake. So I'm sure we can rectify that. This is supposed to be permanently black. Okay. So some people have curly brown hair turned permanently black. Now, if you look at the chapter that is there in the textbook, the main topic of the chapter is called trigonometrical ratios. So they have used the word ratio. Okay, we talk about trigonometrical ratios. Now, what do you mean by a ratio? Ratio means you have two values of the same type being divided. Okay, so we have a numerator divided by a denominator. That's what a ratio means. Okay, you are basically comparing two things of the same type. So, when we come to trigonometry, once we have this poem of some people have curly brown hair turned permanently black, we concentrate on the first alphabet that is there. So, S, P, H, C, B, H, T, P and B. We concentrate on the first alphabet that is there. The first S stands for a sine theta. Okay, it's a sine theta, not a sin theta. So we have S for sine theta equals P standing for perpendicular and H standing for your hypotenuse. So a sine theta is equal to perpendicular divided by the hypotenuse. Okay, so that gives us the first formula that is there. So we have sine theta is equal to perpendicular divided by the hypotenuse. That means the sine gives you a ratio between the perpendicular and the hypotenuse. Okay. Similarly, if you go to the second line gives us C for cos, B for base, H for the hypotenuse. So C, we get cos theta is equal to B base upon H, the hypotenuse. Fair enough? And the third one, which is your T, stands for tan or tangent. So a tan theta is equal to perpendicular divided by the base. So we have tan theta is equal to perpendicular upon the base. So I hope this is clear. So we have the poem first. Some people have curly brown hair turns permanently black. From there, the first line gives us the first formula, which is sine theta is equal to perpendicular divided by the hypotenuse. Cos is equal to base divided by the hypotenuse. And tan equal to perpendicular divided by the base. So this gives us the first three formulas that is there. Now, okay. So now what you try to do is you try to remember this in this particular order. Okay, so you try to remember it as sine, cos, tan, cot, sec, and the cosec. Please again remember it in this particular order only. Okay, sine, cos, tan, cot, sec, and a cosec. What this does is that it tells you which ones are reciprocal to each other. So we have sine and a cosec which are reciprocal to each other, cos and a sec which are reciprocal, tan and cot which is reciprocal. So what you can write from here is you can write, or you can say that sine theta is 1 by cosec theta, or cosec theta is 1 by sine theta. They are reciprocal. Okay. Similarly, cos is 1 by sec, sec is 1 by cos, tan is 1 by cot, cot is 1 by tan. So they are reciprocal to each other. So when we have learned that poem about some people have curly brown hair turned permanently black, we got the first three formulas. Okay, we got sine as perpendicular by hypotenuse, cos as base by hypotenuse, and tan as perpendicular by base. Now we come to the remaining three formulas. Now we come from here. Okay, so cot, which is the reciprocal of tan. Because cot is the reciprocal of tan, this becomes reciprocated. So cot becomes base upon perpendicular. Sec, which is the reciprocal of cos, then becomes reciprocal of this one. So when your cos is base by hypotenuse, sec then becomes hypotenuse by base. So they reciprocate. Similarly, cosec, which was the reciprocal of sine, then becomes hypotenuse by perpendicular. So your cosec becomes hypotenuse by perpendicular. So I hope this is okay. Then we come to the seventh formula that we have, which is this tan theta. This tan theta is equal to sine theta divided by the cos theta. Okay, so we have tan theta is equal to sine theta divided by the cos theta. Okay, so you can remember here, tan is equal to a sine divided by cos. Then cot being the reciprocal of tan. Okay, so since tan is sine by cos, cot becomes the reciprocal of that, or cos by sine. Okay with that? Then you can even try and remember in this formula. Again from here, try and remember it. Sine as 1 by cosec. So you can write here as sine theta is 1 by cosec theta, or the opposite way around. Cosec theta is equal to 1 by sine theta. Okay. The next one, cos is equal to 1 by sec. So we get cos theta is equal to 1 by sec theta, or the reciprocal, or the opposite way around, sec is equal to 1 by cos. So we get sec theta is equal to 1 by cos theta. Similarly, tan as 1 by cot. So tan theta as 1 by cot theta, or the opposite way around, cot is 1 by tan. So we get cot theta is equal to 1 by tan theta. So that's the basic formula. Okay, so we get the formula for a sine, cos, tan, cot, sec and a cosec. Again, tan being sine by cos, and then the ones which are reciprocal to each other. Now we come to the square formula. Okay, we come to all the formulas which have squares in them. Again, try to remember it in that particular order only of sine, cos, tan, cot, sec and the cosec. Okay, so remember it in this particular order only. Now these square formulae become a bit confusing to remember at times. So this is one of the easiest ways to remember. Okay, remember, you have to remember which are the ones which are related to each other when you are doing those sort of sums. So try and remember that these first two are related to each other. Okay, so we have sine square and a cos square being related to each other. If you can remember which are related, it's easier for you to do your sums. So sine square and cos square are related. So in that sense, you can write sine square theta plus cos square theta gives you a 1. Okay, so sine square theta plus cos square theta will give you a 1. So that gives you the first. These are of course brought from this formula only. So sine square theta plus cos square theta gives you a 1. Okay, if you take this cos square that side, then sine square theta is equal to 1 minus cos square theta. Similarly, if you take the sine square that side, cos square gives you 1 minus sine square theta. Okay, so remember that sine square theta and cos square theta are related to each other. Sine square plus cos square will give you a 1. When you come to this part, this is where a lot of you tend to get confused. Okay, so one of the easiest ways to remember it is in this form. Sine square plus cos square, these two are related. When you come here, you will read it like this. Leave one gap and come here. Okay, so these two are related and then these two are related. That means when you are relating, you got to remember when you come to this, 4 of them, you got to remember that the C and the C are related to each other. That means cot square and cosec square are related to each other. Okay, so you remember it in this particular order only. Try and remember that sine square and cos square are related. Once you remember that sine square and cos square are related, then you remember that the C and the C are related. That means cot square and cosec square are related. The two C's are related. That leaves you with a tan square and a sec square to be related. Now you remember it in this particular order. When you look from the top, we have to remember it as 1 plus. Okay, so 1 plus tan square will give you a sec square. Okay, from the top if you look at it, 1 plus tan square will give you a sec square. Similarly, 1 plus cot square will give you a cosec square. Okay, so 1 plus tan square, sec square, 1 plus cot square, a cosec square. And if you look from the bottom up, then cosec square minus cot square will give you a 1. Okay, cosec square minus cot square will give you a 1. Similarly, sec square minus tan square will give you a 1. So you try and remember it in this particular order. Okay, so if you are reading from the top, it is 1 plus. So 1 plus tan square gives you a sec square. 1 plus cot square will give you a cosec square. But if you are reading from the bottom up, then cosec square minus the cot square will give you a 1. Sec square minus the tan square will give you a 1. So that brings us with formulas number 2 and 3. So if you are looking at the second formula, 1 plus tan square gives you a sec square. 1 plus tan square gives you a sec square theta. Okay. If you take this 1 that side, then tan square theta is sec square theta minus the 1. And this one is the one looking from the bottom. So a sec square minus the tan square will give you a 1. Similarly with the third formula, reading from the top, 1 plus cot square gives you a cosec square. 1 plus cot square gives you a cosec square. Take this one that side, cot square theta gives you cosec square minus the 1. And then reading from the bottom, cosec square minus the cot square will give you a 1. So that's as far as the formula is concerned. Now, one of the key areas where a lot of you tend to make a mistake. Okay, please try to understand this. One of the key areas where a lot of you tend to make a mistake is this. When we look at a sine theta, okay, a sine theta or maybe a cos theta or any of the formulae, a sine theta is a single value. Okay, it gives you a single value. Sine theta is nothing but a ratio between the perpendicular and the hypotenuse. That's what sine theta is. So this sine theta is a single value. Sine theta is not sine into theta. Okay, this is not sine into theta. Please try and remember it. That a sine theta is not sine into theta. They are not two separate values. Sine theta gives you one single value. Okay.